Hello, Math 30-1. We're looking at lesson 4.1, angles and angle measurement. This is our first lesson from trigonometry. So angles measured in a counterclockwise direction have to be positive. So when we're measuring an angle, if we go counterclockwise, we're going to have positive angles. So that's what you learned in Math 20-1. What we're going to include this year is if we go clockwise, we're actually going to have to include negative angles when we're talking about angles. So this is 1 radian. Whenever you have a triangle and you divide up a piece of the triangle into its radius, so we have the radius, the distance along the circumference, which is this part is the radius, and then we have the measure going to the center on both sides as it connects to that AB point. The angle that is made between them is called 1 radian. So we, in 20-1, looked at degrees, and now we're including this new measurement of radians. So angle AOB measures 1 radian. So when we look at a circle, in the past we've said that a circle is equal to 360 degrees. But now we're going to start looking at this value of 2 pi is equal to 360 degrees. So 1 full rotation is 2 pi or 360 degrees. 1/2 of a rotation is 180 degrees, which means that half of 2 pi is pi. So that's pi radians. And then if we were to divide 180 in half, that would also make sense with our radian angles. So that would be pi divided by 2. And then let's say we're talking about 45 degrees. That would be then pi divided by 4, meaning 180 divided by 4 will give you 45 degrees. So example number 1, they want us to draw each angle in standard position. They want us to change each degree into radians, and each radian measure to degree measure. So give your answer in both exact and approximate measures if necessary to the nearest hundredth of a unit. So we need to include exact and approximations. So we'll start with A. So A means that we are going clockwise. So we know that going here up to here would be 90, 180, and 270 would take us 3/4 around the circle and end up right there. So that is where our terminal end will fall. So this is where our terminal arm is. So that distance that we've just traveled is negative 270 degrees as an angle. Now we need to convert this. So how we convert degrees to radians is we multiply by pi over 180. So if you want the approximation of that answer, you're just going to put that directly in your calculator. So negative 270, we're going to multiply by pi over 180, and you should get this negative 4.71. Now if we want, so this is the approximation. Now if we want exact, what we're going to do is take negative 270, we're going to divide it by 180 and change it to a simplified fraction. And that's where you go math, enter into your calculator, and you should see that it simplifies to negative 3/2, and then you put in the pi value. So that is our answer in radians. And we're going to repeat that for B, C, and D. So B is 150, that's going counterclockwise, so this would take you to 90. And then if we were to continue, it's going to stop right here approximately, and so our terminal arm will be here. So this angle is equal to 150 degrees. So just like in the previous step, we're going to take that 150 degrees and we're going to multiply by pi over 180, and that converts it into the other measurement of angles, which is radians. And so you should be getting 2.62. Now that is the approximation. If you want exact, you're going to go 150 divided by 180. You're going to change it to a fraction, which is 5 over 6, and then multiply the pi in, and so that would be an exact answer. The second you multiply pi in there, it's not going to be exact, so it's going to change our actual answer. So we need to, in this case, we're showing both. C, we're taking 7 pi over 6. Now to draw this, I find it's easier to convert first. So we're going to take 7 pi over 6, and we're going to multiply it by 180 over pi. Okay, so that's how we convert from radians to degrees. So you're going to multiply by, so 7 pi divided by 6, we're multiplying that answer by 180 divided by pi. And you should get that that is equal to 210 degrees. And so we just need to draw that now. 210 is a positive number, so we're going counterclockwise. So that would end us or take us approximately here. So make sure you have your arrow going counterclockwise to show positive angles. And for D, we have negative 1.2. Now, if you don't see that degree symbol, that means you are in radians. So negative 1.2, we're going to have to multiply by 180 over pi. And you should get that it's about negative 68.75 degrees. So make sure you put that degree symbol when you're writing the degree answer. So we are going now clockwise. So we know that halfway is 45, so a little bit more. So I would say about here, and then show the arrow going clockwise. Okay, so that's how you show your angles. Then we have coterminal angles. So in this case, what we want to state is that when we have coterminal angles, anytime you land in the same position again and repeat that same position, you're going to get a coterminal angle. For example, these two are coterminal, 50, and if you add 360 degrees, which is one full rotation, that takes you to 410. So these are coterminal angles. For example, you can take any angle and either add 360 or subtract 360 to get to their coterminal angles. Now, in this case, I'll show you why pi over 4 is coterminal with 9 pi over 4. Well, what we're going to do is we're going to add 2 pi, which is the equivalent of 360. So I want to work with fractions, so what I'm going to do is get common denominators. I'm going to multiply the bottom by 4 and the top by 4. So that's going to be pi over 4 plus 8 pi over 4, and that gives me 9 pi over 4. So by adding 2 pi or subtracting 2 pi, you get to the next coterminal angle. Okay, so that will happen also with 40. If I subtract 360, I get to negative 320 degrees. So these are coterminals. So let's look at, they want a positive and a negative coterminal angle. So I'm going to start with the positive one. You're going to go 270 degrees and you're going to add 360 degrees. So 270 plus 360 gives us 630 degrees. So that is coterminal to 270. Another coterminal angle would be 270 subtract 360. So if I want to get the negative one, you just take those two numbers and subtract them. And you get negative 90 degrees. So there's one positive, one negative measure that is coterminal with it. Our next one. So to get to the positive one, we're going to add 2 pi. Now, in order to get to that value, we have to go negative 5 pi over 4. We have to add with common denominators. So we're going to have to multiply the bottom by 4 and the top by 4, which gives us 8 pi over 4. So negative 5 pi plus 8 pi is equal to 3 pi over 4. So that is coterminal with it. And then to get the negative one, you're going to have to subtract 2 pi. And we know from the previous example that 2 pi is the same as 8 pi over 4, so we're going to subtract 8 pi over 4 to just simplify our work. So that'll be negative 13 pi over 4. The common denominator, the denominator doesn't change. So that one's the positive and negative. Let's do the same thing for the next one. So we're going to add 360 to get to the positive coterminal angle. So 740 plus 360 gives me 1,100 degrees. And then the negative one, 740, we're going to have to subtract 360. But if you subtract 360, that's going to give us a positive coterminal angle. So what I need to do is subtract another 360 degrees from that answer. And that's going to give me 20 degrees. And then subtract another 360 degrees, because my goal is to get one negative angle as well. I got a positive one, but I need a negative one as well. So subtract another 360. So keep subtracting 360 degrees until you get an answer that is negative. And in this case, it's going to be negative 340 degrees. So those are your coterminal positive and negative answers for each. Now there's multiple answers as long as one's positive, one's negative. So there's infinite number of coterminal angles because you could go 100 times around the circle one way and then the other way. So you arrive back at the same terminal arm. So you can add or subtract 360 n, meaning how many times you're going around the circle, or you can add or subtract 2 pi n if you're working with radians. So this is called general form. Okay, so general form is when you have this addition or subtraction that gives you every possible angle around. Example number 3. We want to write an expression for all possible angles that are coterminal with each of these angles. Identify the angles that are coterminal that satisfy 360 from negative 360 to positive 360, or negative 2 pi to positive 2 pi. So let's start with figuring out what coterminal angles go from negative 360 to positive 360. Well, I'm already past negative 360, so that means I'm only going to have to add 360 until I get every value between negative 360 and positive 360. So if I add 360, I get that negative 140 is coterminal, and if I add another 360, I get that 220 is another coterminal angle to it. Now if I add another 360, that's going to take me over the 360 max, because this is my domain that I'm working with, so I would stop there. And then to figure out any possible answer that is possible to make it the general form, so this is called general form here, you're going to take the smallest positive answer, which is 220 degrees, and you're going to add and subtract 360 degrees n. And n can be any natural number, meaning it can be, you can go around the circle once, twice, and you can keep going around. So that's what that stands for. Now we're going to do that for 360. We're going to actually subtract 360 because we're above 360. So we have to subtract 360 to find out which angles are coterminal between negative 360 and positive 360. So our first one would be 290. That's coterminal, and it's between the domain that they're giving us. And if I subtract another 360, I get negative 70. Now if I subtract another 360 again, that's going to take me past my domain, so I stop there. So our smallest positive angle is 290, so for general form we're going to go 290 degrees plus minus 360 degrees n. And n is an element of natural numbers, meaning n can be only numbers 1, 2, 3, 4, 5, etc. Now for this next one, we know that 9 pi over 4, we're going to have to actually, if we look previously, so when we had 9 pi over 4, that's going to be over 2 pi. So that's over 2 pi. So we can only go from negative 2 pi to positive 2 pi. So that means we're going to subtract 2 pi to that value and keep subtracting until we get between negative 2 pi and positive 2 pi. So 9 pi over 4, we're subtracting 8 pi over 4. And so that gives me pi over 4. And now I'm going to subtract from pi over 4, I'm going to subtract another 2 pi. So that's going to be pi over 4, subtract 8 pi over 4. So that gives me 7 pi, negative 7 pi over 4. Okay, so those are our two coterminal angles that are between negative 2 pi and positive 2 pi. And our general form would be taking the smallest positive one, which is pi over 4, adding and subtracting 2 pi n, where n is an element of natural numbers. So instead of using the 360, the only difference is now we put 2 pi instead, because we're in radian form. So that's what coterminal and general form looks like. So now we're going to talk about arc length. So when we are creating that 1 radian, that's creating an arc. So it's creating an arc, which is this distance right here, and we use the letter A to represent it. Now we're going to use a formula where the angle is equal to the arc length over the radius. So those are always equal to each other. The angle that you have in between is going to equal your arc length divided by radius. Okay, so we need to make sure that we're in radians when we calculate this, that both your A and your R are measured in the same units as well. So your angle is always going to be in radians, and A and R are in the same units. It doesn't matter what units. So example number 4, they want us to calculate the A value. So first of all, we need to convert the angle into radians. So angle is equal to 75 degrees. We're going to multiply by pi over 180. And we can be in decimal form here. So we're going to get approximately 1.31. Now, if you want your answer to be exact, you could have done 75 over 180 and then changed it to a fraction, but we're going to have to round anyway at the end, so we're going to round to, right now, the nearest hundredth, and then our final answer round to the nearest tenth. Okay, so once we have that, we're going to use the formula. So remember, the formula is just about rearranging. So if I have theta is equal to A over R, R is equal to A over theta. And then A is actually equal to R times theta. So that's how we rearrange the equation. So in this case, we want to solve for A, so we're going to take our radius, which is 8.7, and we're going to multiply it by the A value, which is our theta, which is 1.31. And you should get 11.4 centimeters. Now B is already done for us, meaning it's already in radians because you don't see that degree symbol. So in order to calculate our R value, it's just about taking A and dividing it by our theta value. So A is 4.7 and we're dividing it by 1.8. So that's an easier step here. And you should get 2.6 to the nearest tenth. And our last one, the units are the same, so in order to find our theta, it's just going to be A over R. So our A is 13, Our r is 5, divide those two numbers. You get 2.6. And we don't include units. You don't have to write anything when it comes to radians. Example number 5. They're giving us that the distance of the arc is 8,952 kilometers, and we know that the 55 degrees is that angle. So we need to start by, if we want to find out the height of the satellite above the surface of the planet to the nearest kilometer, we need to find then the radius. Okay, so what we're going to do is we're going to first start by converting 55 degrees into radian form. So we're going to multiply it by pi over 180 degrees. Now, if you want exact answers, you can just go 55 divided by 180, change it to a fraction, and that would be equal to then 11 over 36, and then we can put in the pi value. So that's the exact angle in radians. Now, part 2 is where we take our formula. We know that our theta is equal to a over r. And we already know our value of theta. So that's going to be 11 pi over 36 is equal to a. We already know the distance is 8,952 over our r value, which is what we're trying to solve for. So what we can do is rearrange the formula to solve for r. We can multiply the other side by r, and that's going to equal 8,952, and what we're doing is we're actually dividing that answer by 11 pi over 36 because we're moving that 11 pi over 36 to the other side. So you can put this into your calculator. It does want our answer to the nearest kilometer. So when you're dividing, I like to put the 11 pi divided by the 36 in brackets. And you should get that the radius is equal to 9,325.66 kilometers. Now the height of the satellite above the surface of the planet is to the nearest kilometer. What we're trying to find, since the full radius equals 5,000 kilometers, we subtract the radius of the circle that we just found to find the height of the satellite above the surface. So we still need to take our r value and subtract 5,000 kilometers. Okay, so we're going to take 9,325.66 and subtract 5,000. And its height of the satellite above the surface, when you subtract the two values, should be 4,325.66 kilometers, but we need to round to the nearest kilometer. So we're going to round up to 4,326 kilometers as our final answer. The reason being we wanted just this value, and then this value right here was 5,000, so that's why we had to subtract it at the end. Example number 6. We have an angular velocity describes the rate of change in a central angle over time. For example, the change could be expressed in revolutions per minute, so that's RPM. Radians per second, degrees per hour, and so on. All that is required is an angle measurement expressed over a unit of time. So Earth makes one revolution every 24 hours. Express the angular velocity of Earth in 3 other ways. Okay, so what we can do is we can write it as we know that there's going to be 1 revolution per 24 hours. And we know that degrees, there's 360 degrees in 1 revolution. So this is where I'm using my degrees and converting it over time. So degrees over time, or degrees per hour. So that's what I'm doing in this case. Now what happens is these two guys cross each other off, which leaves us with 360 over 24. And so I'll just divide those. 360 divided by 24 gives me 15. So that's going to be 15 degrees per hour. So that is one way to express that. So that's one method. A second method is I can do rads per minute, radians per minute. So I know again 1 revolution over 24 hours. I can multiply it by 2 pi over 1 revolution instead. And then what I'm going to do is multiply by 1 hour is equal to 60 minutes. Okay, so this is converting to radians per minute. And the previous one I converted to degrees per hour. And so what will happen is these guys will cross each other off, and I'll get my answer. These hours will cross each other off, and then I'll have radians per minute. So the tops will all multiply together. So 2 pi is left at the top, and you're dividing it by 24 times 60, which is 1,440. So to get an exact answer, I'm only going to divide the 2 and the 1440. And so that's going to give me, as a fraction, pi, because I put the pi in, because it's 1 pi over 720, and that's going to be radians per minute. Radian per minute. And the third method I'm going to convert to is revolutions per minute. So I know that there's 1 revolution per 24 hours, and I'm going to multiply it by 1 hour is over 60 minutes. The reason being, the hours will cross off, leaving you with the units revolution and minutes. So 1 over 24 times 60 is equal to 1440. And that's going to equal that same value. You don't simplify any further. The only thing I'm going to express it as is just the units. I'll have the units. So I'll put 1 over 1440, and that's going to be revolutions per minute. Done. So whenever you want to get rid of something, just multiply it by whatever is at the bottom. You would then multiply it to the top. Or if you want to get rid of something that's at the top, you multiply it to the bottom of the fraction. So those have to cross off. They have to be on opposite levels to cross each other off. Question B. An electric motor rotates at 1,000 revolutions per minute. Okay, so we have 1,000 revs per 1 minute. What is the angular velocity expressed in radians per second? So we need to convert to radians and then per seconds. So first of all, we're going to have to convert 2 pi. We're going to need 2 pi there for radians at the top. So that way we have radians at the top per second. And 2 pi is equal to 1 revolution around the circle. And then we're going to need to get rid of minutes. So minutes has to go at the top, and there is 1 minute in 60 seconds. So as you can see, the minutes will cross each other off, the revs will cross each other off, leaving us with 2,000 at the top divided by, so 2,000 pi, we need to include that, over 60. And so the only units left are radians per second. So 2,000, we're going to divide by 60 and get 33.33 pi radians per second. Okay, so that's how we get that. And our last example is a bicycle wheel completes 10 revolutions per 4 seconds. 10 revolutions per 4 seconds. We need to express our answer as degrees per minute. So we need to first, we need to multiply this by 360 degrees over 1 revolution, and that's how we get rid of the revolutions. And then since we want minutes, we're going to have 60 seconds at the top so that the seconds will cross off over 1 minute at the bottom. And then we're going to multiply all those numbers at the top together. 10 times 360 times 60 gives us 216,000 over 4. And you should get that that's equal to 54,000, and that will be degrees per minute. And that's it for lesson 4.1. So the idea was to be able to convert from degrees to radians and radians to degrees, be able to do coterminal angles and general form, and then work with the arc length. The arc formula, which is the formula